Okay, grade nines. Good morning. Happy Monday. How are we today? Week 2. I think this is after, 39 weeks left, including this one. For those of you who are counting. I think grade 9 is done. Your attendance question for today is this. I would like to know what your favorite time of the year is. And you can get as specific or general as you would like. You could give me a date and time. You could give me just kind of a general season. What's your favorite time of year? And we're going to start with Abdel. Favorite time of year? You don't know. You don't have a particular time of year where, like, yeah, I love this part. No idea. You love them all equally. Okay. Gurman. Christmas time. Zara. Summer. Kenzie. All right. Kenzie emailed me. Kenzie's going to be away today. Gavin. No Gavin. Matthias. Christmas. Genesis. October. Why October? Because Halloween. Alex. Winter. Faison. Christmas time. Justice. Summer. Daria. Summer. Jacob. Winter. Bowden. Christmas. Is this your first day here? Were you here last week at all? You don't understand. Okay, we'll have to talk. Acom. Summer. Scarlet. Fall. Japrit. Sorry? Summer. Khaled. No Khaled this morning? Jeremy. Summer. Messiah, I don't see. Josh. Summer. Lucas. Sorry, where's Lucas? Over there. Winter. Bilal. Summer. Mitab. Winter. Sukman. Probably summer. Sean. Winter. Emerson. Summer. Hassan. Sorry? Where are you, Hassan? Right in front of me. Hassan Joe. Winter. And Carson. Where's Carson? What was your answer, Ron? Winter. Cool. So I'm missing 4. Okay, if you haven't got your stuff out, please do that. We're going to briefly go over what I gave you Friday. We just review of addition and subtraction, looking at number lines as it was necessary. I gave all of you number line. Because you're not going to get a calculator this chapter or next chapter. Where's your last one? Oh, you were. Okay, so get your workout, compare what you got with what I got. I know I did provide this last week for anyone who was ready to check their work. Comments, questions, concerns on any of it, let me know. There's the first 9. Flipping the page. There was the next big chunk. Whether it was in your head or using the number line, it was just an exercise in mental arithmetic. If you didn't get them done, like you were away last week, don't just fill it in. I am recording videos. I am going to put them up on YouTube. You can go reference them. I don't want you to do them. Don't just fill in answers to this, because you're also not going to have enough time to do that. And those are the bottom 8. Compare what you got with what I got. If you made a mistake or I made a mistake, don't assume it was you. Again, you're not going to get a calculator for this first chapter. It's all going to be mental arithmetic or using that number line. Okay, there's 1 to 22. Okay, here's the bottom chunk. Comments, questions, concerns on any of them, let me know. If you feel like I made a mistake, let me know. Hassan Jode, I have not forgotten the deal we made regarding finding my mistakes. In fact, I went to Costco this week and the candy's still not cheaper, so you gotta wait a little bit longer. But there's Christmas stuff out, so that's fun. Here's this page. Compare what you got with what I got. So there's A through X. And then here's Y through the double letters. Again, there's no shame. I don't want you guys to feel too proud to use whatever tools you need. If you're making mistakes and you're doing it in your head, you use the number line. If there's no reason to not use that tool. If you insist on doing it in your head, then we will start drilling. And there's all sorts of different mental techniques we can go over too, how you would add some of these things together. If you're interested in any of those, let me know. But so many of those that I know do get discussed earlier, so in your education. So I won't necessarily spend a lot of time doing that unless you want. Okay, so today's stuff. Flip the page. Find me this. We're looking at multiplication. And division? Yeah, multiplication and division today, because they're basically the same thing. What is multiplication? Multiplication is repeated what? What was the purpose of multiplication back when you learned it in elementary school? Why did we introduce it? It is, in fact, repeated addition. Sweet. The reason we do it is to take long lines of addition and just condense them. So 3 times 2 actually means we can write it as 3 groups of 2 multiplied together. Or we could write it as two groups, sorry, that's wrong. That should be added. Oh my gosh. It's not exponents, guys. A group of 3 2's added together, or it could be written as a group of 2 3's added together. 3 times 2 is 3 2's added, or, multiplication works the other way. It would be 2 3's added. Either way, it doesn't matter which way you write that. 3 times 2 forever and always will be 6, someone whispered. Cool. And then when we bring in the negatives, if multiplying with one negative number, it's repeated subtraction. So the number gets more negative. So if I have 3 times negative 2, that's the same thing as negative 2 plus negative 2 plus negative 2. I want to put that negative 2 in brackets just to make sure we're really cool with it, what that looks like. And so if I have 3 negative 2's, well, that's just same as negative 2 minus 2 minus 2. So the number's getting smaller, so that thing will forever be negative 6. And likewise, if I have negative 3 times 2, we could write it the same way we wrote it up here. That could be 2 groups of negative 3 added together, which is the same thing as negative 3 minus 3, which is the same thing as negative 6. It doesn't matter which one is negative. The result is the same. Multiplication can be written a bunch of ways. It doesn't matter. You can write it as 3 times 2. We're going to be working with variables, especially when we get into the exponent section. So we'll likely stop writing it this way. We'll write it like this. The brackets around the 2 and that 3 written out front with nothing in between them means that this is 3 times 2. Or you can see it written as 2 times 3. You will almost never see it as 2 times 3, like that. When we have a set of brackets like that, the number that's not in the brackets will always come out front. So while this isn't wrong, you will almost never see it. There's some more though. Sometimes you'll see this with both of them in brackets. Sometimes you'll see it like this with that dot notation. They all mean the exact same thing at this stage. They won't always mean the same thing. These two specifically, as you guys go off and study further math, these two will actually end up being different one day, but not today. And then anything multiplied by 0 is always 0. Because if you think about what multiplication is repeated addition. If I have 3 times 0, that means I'm adding 3 together no times. If I'm never adding the 3 together, there will never be anything there. And it doesn't matter what you're multiplying this thing by. If I want no groups of repeated addition, you're always, always, always going to end up with nothing. Where did I put that page? So then all of these things, and getting comfortable with that idea of repeated addition, remembering that that's where this actually came from, is a useful tool. It can help you figure things out, like multiplying these negatives together. Someone hanging out in the hallway? I do have someone hanging out in the hallway. I can see your reflection in the whiteboard. Come on in. Hi. Yeah. Which one? Zara? Yeah. So I've also given you guys, if you were here last week, all of you should have a multiplication table. So some of these are math facts that I would expect you to know. Others of these, as the numbers get larger, I think that multiplication table goes up to 20 times 20. Some of these bigger ones, I don't necessarily expect you to have memorized. But again, I'm not giving you a calculator, so use the tool that's provided to you. If you can do it in your head, great. We'll review longer multiplication here in a sec. But 3 times 3? Someone said 9. Fantastic. 3 times negative 3? Negative 9. Negative 3 times 0, anything times 0 is? 0. 0 times 6? 0. Negative 5 times 7? Negative 35. And positive 3 times negative 2? Negative 6. We can write the negative rules up here. I'm going to write them again on the next page, but we'll write them up here. If I have a positive and I'm multiplying it with a negative, or if I have a negative and I'm multiplying it with a positive, that is always going to be what? That will always equal a negative value. For the same reason that we wrote these things up. If I have a positive times a negative, it's repeated subtraction of whatever that negative value is, however many times the positive number exists. So if I have a positive times a negative, it's going to be negative. If I have a negative times a positive, it's going to be a negative. This again, someone asked me last week if this was true for addition. This isn't. Like, people will make this mistake with addition. If I add two negatives, so if it's a negative plus a negative, is that going to be positive? No. If I have a positive plus a negative, is that going to be negative? No. That's not necessarily. Only true always. It's only always true for multiplication. And then if I have two of the same sign multiplied together, if I have two positives multiplied together, or if I have two negatives multiplied together, that will forever always be what? If I'm multiplying a positive and a positive, that value is positive. And if I have a negative times a negative, that value is also going to be positive. And I'll show you on the next page kind of some reasoning for why this is this way. Let's go down here to the bottom. Do we remember long multiplication by hand? You remember how to do this? Okay. So let's do a couple examples of it just to make sure we're all on the same page here. Some of you were nodding, some of you were staring blankly. So if I have something like 13 times 2, and I want to do that using long multiplication. First of all, writing it like this is not going to be a great way to write it. So what I'm going to do is I'm going to rewrite it. Give me our mouse. I'm going to rewrite it as 13 times 2, and we're going to stack them. To do long multiplication, I'm going to take whatever's down here and I'll multiply by both of these digits. So 2 times 3 is? 2 times 1 is? Fantastic. And so 13 times 2 is 26. Nice and easy. Let's make it more interesting, shall we? Let's go 13 times 5. So I'm going to start it the same way. I'm going to go 5 times 3. Yes, sir. So 13 times 5 is 15. So the 5 comes down. Where does the 10 part of the 15 go? It's going to go above the 1 here. Because 5 times 3 is 15. So I'm going to have these 15s, but then I'm also going to multiply this 5 here by this group of 10 here. So to deal with that properly, what we're going to do is we're going to take that 5, we're going to multiply it by this 1, and we're going to add it to that extra 10 that we got when we multiplied it by the 3. So 5 times 1 is 5, plus this one is 6. Or I'm sure some of you had memorized that 13 times 5 was 65. Questions about what I just did there? Is this coming back to us from years gone past? Okay. How about 13 times 11? Again, let's rewrite this thing. Hold that thought. Duden, good morning. One sec, guys. Chat amongst yourselves. I gotta pull something up here. you got switched into a different math class. So you have a different block in your first period class. So I'll pull out your schedule here and I'll show you where you're supposed to be. Yeah. Right here. Right here. Okay. So you actually have an ELL block right now? Is this you? Did you do Nuezo? Yeah. So you have an ELL block right now. Yes, this is your schedule. You removed classes. You've been put in this class. So you need to go down to the library. Into the library. Do you know where the library is? So do you know where the conference room in the library is? No? Okay, I'm going to take you down there right now. Okay. 13 times 11, how do we do it? Yeah, man.
1 times 3 is 3.
You bet.
And you go 1 times 1, so 1 times 1 times 3. And we'll equal 4.
Ooh, careful. You're right. We are gonna do the 1 times 3. 1 times 3 is 3. But there's something we have to do now that we've dealt with this one. How do we represent that? Who remembers? What the next step? 2-digit numbers. Yes, I saw your hand first. Carson, right? Yeah. Yeah, we have to drop a 0 down here. Because effectively what we're doing is we're doing 1 times 13, and then we're going to do 10 times 13, and we're going to add those two values together. Is effectively what we're doing here. So because we've done this, we've finished with this one already, we have to add a 0 for this placeholder. And then 1 times 3, and keep going with what you were saying. 1 times 3 is 3, which we're going to add together and get 4. And 1 times 1 is 1. 3 plus 0 is 3. 1 plus 3 is the 4 you said earlier. 1 alone is 143, and there it is. It gets more interesting. Let's change this one. Instead of 13 times 13, we're going to make it 13 times 14. Just make it more interesting. If I multiply 13 times 14, the only difference is when I multiply the 4 and the 3 together, I'm going to carry the 1 like we did before. 4 times 1 is 4 plus 1 is 5. And then the next part is the same. Because we've dealt with the 4 already, we're going to toss a 0 down here. 1 times 3 is 3. 1 times 1 is 1. So then adding these things vertically is going to give me 2, 8, and 1. So 13 times 14 should be 182. If I didn't screw that up. Questions, comments, concerns? Okay, so again, you can use your multiplication table. As soon as the numbers get bigger than 20 by 20, then perhaps looking back and doing it long multiplication is going to be the way you have to do it this chapter. Because again, no calculators. Flip the page. So this is my argument for why multiplication, two negatives multiplied by each other is going to give you a positive. If while I'm going through this, this is just my reasoning for why. So if you're looking at this page and you're like, I don't care why, that's fine. At the end of the day, if you recognize that a negative times a negative is going to give you a positive every time, that's cool too. But here's my argument for it. So multiplying two negative numbers gives you a positive number every time, but why? It doesn't make sense to think of a negative times a negative as repeated addition or subtraction. That argument just kind of breaks down, right? So what we're going to do is we're going to use it as, we're going to talk about these positives and negatives as if they were directions instead. Because in math, sometimes that's what positives and negatives mean. So I got Pac-Man on a number line here. And he can move two ways. He can move either forwards or backwards. We're going to call forwards positive. We're going to call backwards negative. And Pac-Man can choose which way to face. He can either look at the negatives and face left, which we'll call negative, or he can look at the positive direction or to the right. And so when we combine the which way he's facing and the which way the which way he's moving and the which way he's facing, we'll get kind of an understanding of why a negative times a negative is a positive every time. So if I multiply two positive numbers together, we have a first positive number, so Pac-Man's facing positively, and because this second number is positive, he's going to move forward. So he's going to move here from 0, because 3 times 1 is 3, and he's going to move out here. Because he's facing and moving in the positive direction. If I have a negative times a positive, the example here works too. If I have a negative times a positive, he's facing the negative direction, and now he's going to move forward. So if he's facing negative and moving forward, he's going to end up moving this way, down here till -3. So another reason why a negative times a positive is a negative, when you think about it using directions. If we take a look at the next one, if I have a positive times a negative, we have Pac-Man facing a positive direction, but we're going to have him move backwards. And so we're going to get him sliding back this way to -3. He's facing positive, moving backwards. And then likewise here with the double negative, when I have a negative times a negative, he's facing negative, but now he's going to move backwards. If he's facing the negatives and moves backwards, he's actually going to move in a positive direction. So he's going to end up traveling this way out here to +3. So a reason appealing to direction as to why this is the way it is. Okay, flip the page. We're going to look at division right away. I want to make sure I have my link, but I'm going to grab my... There it is. My multiplication table, before we do that, I'm just going to review how the multiplication table works. If you've never seen this tool before somehow, it is literally just, I have all the numbers 1 to 20 up to the top, and I've got numbers 1 to 20 down here on the side. And if I want to multiply two numbers together, for example, we were doing 13 times 14, I have my 14 up here, my 13's down here, and I go to where those the row and the column meet, down here at 182. That's how I would use it. If you've never seen a multiplication table before, and there are those of you in here who may not have, that's how we use this tool. You pick one number along the top, one number along the side, and you go to where they meet, and that's where they multiply to. If you haven't memorized it or you don't want to do it longhand. So let's talk about division, shall we? Division is the process of, undoing what we've done. Instead of having repeated addition with multiplying, what we're going to be doing is we're going to have groups getting divided up. So if I have 6 divided by 3, what that means is I want to take 6 and I want to break it up into 3 equal groups. So yes, someone already said it. Those equal groups, in this case, are going to be 2. Because 2 plus 2 plus 2 is 6, 6 divided by 3 then is going to be 2. So then the question is, if 6 is going to be divided into 3 equal groups, how big is one of those groups? Well, one of those groups is too big. That's what division actually means. So if I've got 9 divided by 3, it's the same idea. I want a word problem example of this kind of thing would be like, share 9 pencils between 3 people equally. How many pencils does each person get? 9 divided by 3 is 3. And now we're going to start bringing in fractions. I know some of you said that fractions were your absolute favorite part of math. Some of you said that it was absolutely your least favorite part of math. I'm kidding. No one of you said it was your favorite part of math. But here we go. Let's bring in the fractions. Why are we bringing in fractions now? We're bringing in fractions because a fraction is just a division statement. That's all it is. If you remember, I've written it right here, your division statement, this is the symbol we use for division. This looks an awful lot like a fraction with dots in the bottom, top and bottom. The symbol for division is itself a fraction. So fractions are just division. If I have this thing written this way, 15 over 3, that's the same thing as 15 divided by 3. That symbol is the same. And then, how many of you have used a multiplication chart for division before? Never? Cool, let's do it. So this is a simple one to do, 15 divided by 3. We don't need to do this because all of you will say that 15 divided by 3 is 5. Well, let's show you how that works on a multiplication table. On a multiplication table, what we're going to do is, because we've got 15 divided by 3, we're taking 15. 15 is the result that what we would get when we multiply. And I'm dividing it by 3. So we're going to go over here in the column to wherever we get to 3. 3 is what we're dividing by. And we're going to go down till we get to 15. So 15 is the thing that we're dividing by 3. So here I am in the 3 column. I'm going to go down to 15. And then the result is whatever's over here. So I'm dividing by 3. What am I dividing? I'm dividing 15. Oh, look, it's 5. That's how you use a multiplication table for division. Take what you're dividing by, find what you're dividing, that's the result. So 15 divided by 3, y'all can do in your head, which is great, but now we can use the chart for it too. 15 divided by 3 is 5. Dividing by 0 and multiplying by 0, not the same thing. We have a problem here when we divide by 0. If I have 0 divided by 3, what does that mean? Well, that means I want to take nothing, 0, and divide it into 3 equal groups. If I'm taking nothing and dividing it into groups, the result is going to be, each group is going to be 0 big. That makes sense. Because 0 divided by anything, or we could write it like this, we could say that this is 0 over 3. Nothing broken into 3 groups is still nothing. But what happens if I go the other way? If I'm taking 3, I want to divide 3 up into no groups. No, that if I'm taking 3 and I'm putting all of it into one group, that would be 3. I want to take 3 and I want to break it up into no groups. Conceptually, that doesn't make sense. How do I take something and break it up so I can get rid of it? I have it, and I want to break it up into groups that are none big. In mathematics, we say that that is undefined. It's something undefined. It's something we cannot do mathematically. The rules for it just don't exist. Sometimes if you punch that into a calculator, you'll see the word undefined. You might see it abbreviated as UND. Sometimes you'll see it as error or math error if you punch that thing into a calculator. Because conceptually, it doesn't make sense to divide something into groups that are none big. Even saying it is weird. How many of us remember long division? How many of us are pretty convinced you've never learnt long division? Okay, long division is a useful tool. Let's review it. For a whole bunch of us who perhaps haven't remembered it, that's okay. 24 divided by 2. If you remember your math facts, 24 divided by 2 is 12. If I want to prove that, or if I want to find that using my multiplication table, I'm going to go to the column I'm dividing by. I'm going to go down till I'm finding what I'm dividing. And I'm going to go over and I'm going to get 12. But if you don't have your multiplication table, you don't have your math facts memorized, we're going to bring out long division again, just to review. Here's how long division works. We take the thing we're dividing by, we take the thing we're dividing, 24, and we put it in this weird looking symbol here. We take the thing that we're dividing it by and we put it out front. And now we're going to start dividing it into each part. Does 2 go into 2? Yes, it goes in once. So then I put however many times 2 goes into there, above there, and then I multiply. 1 times 2 is 2, and now I subtract. 2 minus 2 is 0, and I go to my next digit, and I'm bringing the 4 down here now. Does 2 go into 4? Yeah, it goes in twice. So I'm going to put however many times it goes in up top there, and I'm going to go 2 times 2, and I'm going to put that result down here, and 4 minus 4 is 0. So 24 divided by 2 is 12, with nothing left over. If it's been a while since you did long division, that's how you do it. This one sucks to do through long division, for reasons that are going to become obvious here in a second. So if I rewrite it using long division, does 3 go into 2? No. So now we have to look and say, well, 3 doesn't go into 2, so does 3 go into 24? Well, that's what we're trying to figure out. And so if you don't have your math facts memorized, this doesn't help you. Long division isn't going to be a useful tool. So we can go to our multiplication table. Does 3 go into 24? We take 3, we go down until we hit 24. Do we hit 24? Yeah, we do. There it is. 3 goes into 24 8 times. So there's your result. Long division in this case isn't useful because 3 doesn't go into the first digit. Okay, so I've got a couple more. Do I have? Yeah, I got a few more here. And then I'm going to get you guys to practice these last 4, and then you guys are going to work. So if I've got 84 divided by 4, when I've written it as a fraction, that's the same thing as writing it like this. 84 divided by 4. That's the same thing as writing it like this if you're going to write it out using long division. At this point, I no longer care how you tackle something like this. There's all sorts of ways to do this in your head using math facts that you just memorized, using long division, or using the principal multiplication table that I've given you. Some of you might do it in your head this way, and you'll say that, well, 8 divided by 4 is 2, so 80 divided by 4 is 20, and 4 divided by 4 is 1, so 84 divided by 4 is going to be 21. You might reason it in your head that way. That's cool. Some of you might say, I don't want to think about it that much, so I'm going to go and look at my multiplication table. You're going to go to 4. You're going to go down to where it says 84. You're not going to get to 84. You're going to hit 80. But if you think about it, 84 is just 4 more than 80. So that's just going to be 1 more up on the table. So you can argue it that way too. Or we can use long division. 4 goes into 8. How many times? Twice. So then 2 times 4 is 8. 8 minus 8 is 0. Bring down the 4. 4 goes into 4 once. 1 times 4 is 4. 4 minus 4 is 0. So again, 84 divided by 4 is 21. It doesn't matter how you do it, which way you want to tackle it. They all work. How about 91 divided by 7? Does it go nicely? Again, it doesn't matter how you choose to think about it. You can use your long division, you can use your table, you can use your math facts. But I'm going to leave the rest of this for you. What I'd like you to do now, I'll walk around and start helping with those where it's needed. I want you to do these 3. This is going to be the beginning part of your homework. That's homework. Flip the page. I want you to do this page here. This is just looking at repeat a multiplication by positives and negatives. So the first three questions, all it says is determine whether each product is positive or negative. Don't tell me what the answer is, just tell me if it's going to be positive or negative. If I have an even number of positive numbers an even number of negatives, that's positive. An odd number of negatives is negative. These ones I actually want you to multiply. So this one, just tell me if it's positive or negative. These ones I actually want you to do. And then I want you to flip the page, and I want you to do this page here. This is, yeah, I know, it's a lot, but you got 40 minutes to do it. And I will float around and help where needed. You've got your multiplication table. You've got some more techniques here on your market set. Go. And I will help as needed.